Okay, so here we want to find the derivative of this function. And so we're going to remember that the derivative of inverse tangent of x, remember, is 1 over 1 plus x squared. So we're going to use the chain rule for this guy. So the first thing, remember, is we're going to get the derivative of the outside. So the derivative of arctangent is going to be 1 over 1 plus, and then the whole inside of this guy, so this entire thing, squared. So I'm going to have cosine of square root of x squared plus 4x minus 1 squared. So I can either put, let me put it in the same color. Let's do blue. So I'm just going to put this whole thing in parentheses, so squared. So here we use the chain rule, 1 over 1 plus this whole inside squared, and then times the derivative of the inside. So here we have to use the chain rule again. So the derivative of cosine is going to be negative sine, and then you're going to leave the inside alone. So here we're going to leave the square root of x squared plus 4x minus 1. So all that is going to be left alone. And then times the derivative of the inside. So here we've got the square root function. And so we're going to multiply by the derivative of the square root. So remember, the derivative of the square root is 1 over 2 square root of, normally it's x, but this time there's something else inside. There's this guy, so we're almost done. So inside of the root, we leave that alone, x squared plus 4x minus 1. And then times, but I'm actually going to just put it up here to save myself a little room, times the derivative of that inside, which is going to be 2x plus 4. And now I'm done with all of the chain rule action. And I can close that this parentheses right there. That's it. Okay, so here we have some information about a function. We don't have an actual function itself, but we know that f of 3 is equal to 2, and f prime of 3 is equal to 4. So we have the value of a function at a point, and then the value of its derivative. Now, what this is asking me for is the derivative of the inverse at 2. So I need to find the derivative of the inverse without actually having the actual function itself. So this is also the same thing as saying the derivative. So if I just kind of, if you're not comfortable with that notation, this is the same as the derivative of the inverse. There's several different ways to write this down. But this is the derivative of the inverse of f evaluated at x equals to 2. Okay, so to actually find this, we've got our formula that we derived earlier for the derivative of inverse functions. We have that the derivative of the inverse, so f inverse prime of x, is equal to 1 over f prime of f inverse of x. Okay, so that means that we need two things. Now, in this case, since I'm evaluating at a certain value of x, here I'm looking for f inverse prime at 2. So then that means that this guy is going to be also 2. So I need to find those guys. So I can do that. It's no problem. I need to find first f inverse of x, which in this case is 2. Okay, so f inverse of 2, well, what this is saying basically is that when y is equal to 2, what's x? And so you go back to your information, you go, oh, well, when y is equal to 2, x is equal to 3. Okay, so then the next thing you need to find, so basically what you've just found is this guy right here. This is equal to 3 in this case. So then what you need to find is, okay, well then what's f prime at that value that you just found, this guy, what's f prime at 3? Well, f prime at 3, it just so happens that we have it right here. That's equal to 4. And so that's it.